Assalamu alaikum. How are you, students? Hope you all are fine. I know you are missing your school too much, but this online platform, this also gives you a great opportunity to learn. So try to make a best use of it. Dear students of Standard 9, today I'm going to start a new chapter, that is chapter 9, and it is named as Reflection of Light from your physics book. And today I am going to explain nature of light and reflection of light. So let's start the class. Nature of light. What we see in our eyes is what is light. We see trees, the sky, chairs and tables, human beings, but that doesn't mean that these are light. Light reflects from those objects and comes into our eyes, and the retina of our eyes create and send signals to our brain. Then our brain can recognize what is a tree or what is a flower or a human being. So we know light is a form of energy by which we are able to see the objects. When light comes from an object to our eyes, we see that object at the time. The light entered into the eyes forms an image of the object in the retina and develops a sense of vision similar to the object in our brain through a complex process. Men have been trying to achieve knowledge about the nature of light from an ancient period. Once it was thought that light falls on an object from our eyes, so we see that object. But this fact is wrong. Actually, when light comes to our eyes from an object, only then we can see the object. The major properties of light are: light travels in a straight way through a transparent homogeneous medium. Light travels with a definite velocity in a definite medium. The value of this velocity in vacuum is, the velocity of light is indicated by the symbol c. C equal to 3 into 10 to the power 8. Dear students, it will be power. This 8 will be power of 10. So 3 into 10 to the power 8 meter per second. Number 3. Reflection, refraction, interference, diffraction, dispersion and polarization of light take place. These are different phenomena, optical phenomena, which are caused by light. Light is a form of energy. I have already told you, light is a form of energy. Light is a kind of electromagnetic wave. That means it has both electric and magnetic field. Light behaves as wave in some cases and also as particle in some incidents. So, from the previous slide, you came to know about the nature of light and different properties of light. Now I will explain the spectrum of light and sensitivity of eyes to different colors. Spectrum. Look, this is electromagnetic spectrum. There are different kinds of light, but we can see only a few portion of light, that is known as visible light. So, according to the wavelength, light can be classified as radio wave. You know, light is a wave. So, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. The wavelength of gamma ray is 10 to the power minus 14. And the wavelength of X is 10 to the minus 10. Ultraviolet ray sorry, it is visible ray, visible light, 10 to the power minus 6, then 10 to the power minus 2 microwave, 10 to the power 2, then radio wave, 10 to the power 6. So here we can see the wavelength is the least in case of gamma ray, and you know wavelength and frequency are inversely proportional to each other. The more the wavelength, the less the frequency, and the less the wavelength, the more the frequency. So gamma ray is the strongest electromagnetic wave, and its wavelength is the least, that means the lowest, and its frequency is the highest. So gamma ray, X-ray, ultraviolet ray, we cannot see these light by our naked eyes, but we can see only the visible light, which is from 400 nanometer to 700 nanometer, whose wavelength lies between this range. That means 400 nanometer to 700 nanometer, and it frequently comes as your MCQ question, so you must remember this thing. So light is an electromagnetic wave. Every wave has a wavelength, which means light also has a wavelength. So according to wavelength, light can be classified in this way. Okay. Now look, the spectrum is shown. The electromagnetic spectrum includes all kinds of light. The kind that we can see is visible, and many kinds that we cannot see. Okay, so only this portion, visible light, that means 400 nanometer to 700 nanometer is visible light. That is, you know, Vibgyor, that is violet, indigo, blue, green, yellow, orange, and red. These are included in visible light. But ultraviolet ray or infrared ray, then radio wave, microwave, we cannot see these electromagnetic wave by our eyes. So we cannot see if the wavelength is larger or smaller than the range. That means the range of the light which lies above the visible light and which lies below the visible light, we cannot see those light. We can see the electromagnetic wave, and we call the light as electromagnetic wave, that is visible light. The color we see in our eyes are actually lights of different wavelengths. When the wavelength is less, it becomes violet. When the wavelength increases, the light gradually becomes blue, green, yellow, orange, and red. So you can understand the wavelength of violet is the least and the wavelength of the red is the highest. And at one point it disappears. That means after visible range, the light will be disappeared to our eyes. Human eyes cannot see beyond this range, but various insects or other living beings can see outside this range. The sensitivity of human eyes to different colors of light are shown in this figure. So light is an electromagnetic wave. I have told you. Look, this is electromagnetic spectrum. When white light is passed through any prism, then that white light is split into 7 different colors. Look. And among those light, the wavelength of violet is the least and the wavelength of red is the highest. Dear student, now I will explain about reflection. If we talk about reflection, what we imagine? in standing in front of a mirror, but reflection is much more than that, isn't it? If you think about reflection, image can create in your mind, that is, you are standing in front of the mirror, but reflection is much more than that. When light is sent from one medium to another medium, different phenomena occur simultaneously. One of them is reflection, other two are refraction and absorption. That means when light is fall on any plane surface, then these three phenomena can occur. That means some portion of light can be reflected, then some portion of light can be refracted, and some portion of the light is absorbed in that medium when light passes from first medium to second medium. Look here, by this figure I can explain reflection. This is incident ray, and this is the point of incidence. That means, and this is the mirror. So at this mirror, at the point P, a ray is incident. Okay, and a ray is incident, and being getting obstacle on this mirror, the light goes back to the first medium again, and this phenomena is known as reflection of light. So this is incident ray and this is reflected ray. And at the point of incidence, if I draw a perpendicular, that is known as normal. So the angle between normal and incident ray is known as incident angle, and the angle between normal and reflected ray is known as reflected angle. So now the definition of reflection can be given like this way. What is reflection of light? When light traveling through the first medium falls on the surface of the second medium, then a portion of light returns back to the first medium from the surface of separation of two media. This phenomena is called reflection of light. Do you understand, students? Laws of reflection. So here, look, incident ray, reflected ray, and this angle is known as angle of incidence, this angle is known as angle of reflection, and these two angles are equal. Okay. So incident ray, the light ray falling on any surface is called the incident ray. Reflected ray, the light ray that comes back after reflection is called the reflected ray. Normal ray, the line perpendicular to the reflecting surface, is called the normal ray. Angle of incidence, the angle between incident ray and the normal ray is called angle of incidence, and the angle between reflected ray and the normal is called angle of reflection. Now, laws of reflection. The incident and reflected ray obey two simple laws. First law, the incident ray, reflected ray, and the normal at the point of incidence on the reflector lie in the same plane. Second law, the angle of incidence is equal to the angle of reflection. Look, incident ray, reflected ray, incident angle, reflected angle, and incident angle and reflected angle are equal. And first law key, the incident ray, reflected ray, this reflected ray, and the normal all lie on the same point of incidence at the same plane. Okay, and the angle of incidence equal to angle of reflection. I think you can understand the laws of reflection. So for reflection, we use what? We use mirror. So question may arise in your mind, how much will it reflect? That means how much a mirror will reflect. If a mirror is used for reflection, it reflects fully. Look here, a mirror is used for reflection. So here we can see the light is fully reflected. But the word reflection is not only meant for mirror. It may occur between any two mediums. Fresnel's law describes how much it will reflect, and you will learn about it in the higher class. You will learn more things about it in the higher class. So the main thing you must remember, that is the larger the angle of incidence, the more the amount of reflection. In normal glass, light is slightly only 4 to 5% reflected, and the rest is refracted to the glass. And in case of mirror, in the back portion of the mirror there is silver coating, so most of the portion of the light is reflected in the mirror. But if it is considered as normal glass, then 4 to 5% light will be reflected and the rest of the light will be refracted. But if the angle of incidence is higher, that is like 80 degree or 90 degree, then reflected light increases greatly. And you can also make an experiment standing beside a window. Dear students, today I will not explain more. I wanted to explain up to reflection, and in the next class I will explain some more interesting things about light. I think you will enjoy. Dear students, there is a moral for you. If you are the light, you cast away the darkness. Goodbye, everybody.